Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the pH measurement with the glass electrode is reduced to measuring a resulting potential between the electrodes E1 minus E9 with a considerable internal resistance. To the extent there may be some difficulties. The most common are A. Coating or abrasion of the glass electrode membrane influences potential E4 and or E5. B. Non-aqueous or high-resistance solutions influences E6 and E5. C. Blockage or mechanical failure of the liquid junction in the reference electrode influences E7 that prevents the passage of CIK, leaving the circuit open. If the plug-in is partial, an indeterminate potential develops. D. Entry of the test solution into the internal solution of the reference electrode influences E6 and, more importantly, E9, thereby destroying the desired constant potential. E. Variation with time of the asymmetry potential that depends on the nature of the glass, the type of manufacture, the impurities, the gradual dissolution of the glass in the solution, the wear due to erosion of the glass tip, etc. This potential is only a few millivolts, but it remains constant even though the same solutions exist on both sides of the glass electrode. pH instruments have an adjustment to correct for this potential. The temperature variation influences the pH measurement. At constant pH, it reaches 0.2 millivolts per degree centigrade. As in the final indicating or recording or control instrument, the measurement is made in pH units instead of millivolts. It is necessary to compensate for the influence of temperature variations in the test solution. It should be noted that the thermocompensator or resistance probe compensates only the voltage-temperature relationship of the glass electrode, and that it only ensures the measurement of the real pH of the solution at real-time temperature. It does not detect the variations with the temperature of the pH of each solution, which follow a different law from one solution to another, and for which a special compensator would have to be designed for each of them. And for this reason, the measurement of pH is only valid at the temperature at which the solution is found. Here, we can see the millivolts pH relationship as a function of temperature. Although the signal variation in millivolts per pH unit is relatively large, 58.2 millivolts pH at 20 Celsius degrees, the high resistance of the electrode circuit advises the use of a pH amplifier, which, due to the characteristics of the circuit, must have a high impedance, low noise level to reduce errors, and optionally, signal isolation between input and output to eliminate ground loops. Since the reference junction is at a ground potential, the registration or control of the pH once the signal is amplified is carried out in a potentiometer or digital instrument. In the measurement of pH, the coating of the electrodes may occur. In that case, the electrodes behaves as if it were detecting low concentrations of H+ ion, and therefore, the recording instrument would read high pH values. In these cases, it is necessary to periodically clean the electrode with a frequency that depends on each case. There are automatic cleaning methods, ultrasound, jet cleaning, mechanical brushes, that have not yet given a totally satisfactory result, and manual or automatic extraction devices that allow the extraction and cleaning of the electrode without interrupting service. The ISFET transistor electrode is virtually unbreakable, solid state, and provides a very fast response. The sensor has a low impedance pH signal, which gives it great reliability, and has a long life, working in the dirtiest liquids and with most impurities. It incorporates a replaceable reference electrode. The use of a microprocessor brings intelligence to the pH transmitter, providing vibration insensitivity, automatic temperature compensation, and self-diagnosis by detecting sensor asymmetry and alerting the user, thus facilitating the practice of predictive maintenance. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!